Bren, the antiderivative of 3.
3x.
The antiderivative of negative 17. Owen.
Yep.
Antiderivative of negative 17.
Negative 17x.
That's
What?
Well, we tried.
Okay.
Brindley, the antiderivative of x.
Just ruined the game. 1/2 x squared.
And then the antiderivative of x squared. Celine, the x squared antiderivative.
1/3 x.
Okay.
Let me have the next one. Yeah, I got it.
Okay. Let me move down here. Max, the antiderivative of x cubed.
That would be 1/4 x to the 4th.
Okay. The antiderivative of x to the 4th. Evie.
X to the 4th would be 1/4 x to the 3rd, or to the 5th.
One what? X to the 5th?
1/5.
1/5 x to the 5th. The antiderivative of x to the 27th, Braden.
1/28x to the 28th.
Ooh, how about this one? The antiderivative of x to the 1/2. Heidi, what's the antiderivative of x to the 1/2?
1/3 x to the 3rd.
This one right here. Number 8.
2/3 x to the 3rd.
2/3 x to the 3/2. Do we agree with that?
Yes.
Okay. The antiderivative of x to the negative 4/5. Julia?
5 to the x to the 1/5.
5x to the 1/5. Okay. Good. Are you seeing a pattern with our power rule?
Yes.
Okay. I gotta erase these to move us down here. A couple more. The antiderivative of sine of 5x. Isabel, what did your table come up with for that one?
Come on, Miss Newman.
Well, it was impressive, but we're gonna go on.
Time
Anybody
out.
time it?
No.
Ugh.
We were planning on going the whole class.
Well, it'll work. All right, Isabel, number 10.
Negative 1/5 cosine 5x.
Okay, so instead of 5, we have to multiply by the 1/5 to account for that chain rule action. Okay, cosine of pi x. Pierce?
1/pi sine pi x.
Again, we have to do the fraction as the coefficient to account for that chain rule. And then 3x to the 4th plus x squared.
I had a question on it.
Okay, hold on. Aaliyah, give me this one.
That's x to the 5th plus 1/5.
Excellent. Come back to number 11. What's your question, Brittany?
Why isn't it negative? Because we can do like something.
Well, so the derivative of cosine is negative sine. But when we go backwards, we're going to have the opposite effect. So the antiderivative of sine is going to go to negative cosine, and the antiderivative of cosine is going to be positive sine. So now they're going to be switched since we're going backwards, okay? Right? So if we have a function, our derivative is what we're used to doing, right? Well, now we have to go backwards from what we've been doing in our heads with derivatives, right? So if we think of like an order, if we have a function, we go this way for a derivative, we're going to go backwards for the antiderivative. Okay? What's nice about these antiderivatives, though, is we can check our work, right? If you have an antiderivative, if you take its derivative, you should get back to your original function. Okay? And we're going to talk about how derivatives and antiderivatives can kind of cancel each other out. Okay? Now, on here, we had a bunch of notation for derivatives. Do you think there's a particular way we have notation for antiderivatives? Okay, so go ahead and turn to somewhere in your notebook so you can write down the symbol for an antiderivative, and we can kind of talk about some official rules here.
It's gonna be x cubed plus x. It's like an evil movie. Ooh. There's so many things. I'm not a delinquent.
You're not a delinquent.
No. He's trying to convince me to be a delinquent.
All right, come on, smart notebook. Here we go. That's not what I wanted to know. Flashbacks to pre-calculus here for you. You don't remember mathematical induction? The proof that we did?
Oh, that annoying.
That sounds like a Schoolhouse Rock song.
I remember that.
Mathematical induction.
It was just some really long sentence we had to write.
It was more than a sentence.
Yeah.
Okay, so if f prime of x is f of x for all x. Okay. The antiderivative of f prime of x dx. I'm gonna let you.
Einstein.
This is what we call an integral. The integral symbol says, hey, find me the antiderivative. And then this dx right here says, hey, in terms of x. If it's dy, you're finding the integral in terms of y. If it's dt, you're finding the antiderivative in terms of t. Okay? When we find an antiderivative, so since this is f prime, its antiderivative would be the normal function. And we always have to say plus c, because we could add on a constant to where when we take the derivative, what's the derivative of a constant? 0. We go back to what's inside. Okay? So any antiderivative that you find, you're going to tack on a plus c, because there could be some constant there that we don't know, that when we take the derivative, we go back to 0. Okay? Also, what do I want to do here? If we have the derivative of the integral, and we'll talk about this a lot more, but those are going to basically undo each other. The derivative of an antiderivative is just the function itself. It's the derivative of the integral. They cancel out. The derivative of the antiderivative. It's function.
Well, then should that have an apostrophe? No. Okay.
No.
Okay. Well, I did.
For what?
His head is like right in the middle of that function.
Well, placement. The placement is unfortunate. Okay.
Placement over power.
So let's think about some things. What's the derivative of a constant? 0. So the integral of 0 dx, I know that looks weird, is c. The antiderivative of nothing is some constant. Okay? What is the derivative of kx? Therefore, if we take the antiderivative of any numeric value, the antiderivative would be kx and then plus some constant c. So that's what you did in the first part of your activity with the 3 and the negative 17, right?
Do we have to write this?
Yes. Like if you don't have the plus c, I'll take off a point. Like there's an entire point for all of your antiderivatives having plus c.
So,
Okay. Yes.
so every single antiderivative like we ever write will have plus c.
Yes.
So free point to write plus c.
If you want to think of it like that.
Remember?
Okay. Now let's think about this. Our power rule. When we take the derivative using the power rule, we say nx to the n minus 1, right? Well, then what were you doing in your activity today? You are taking x to the n power, and what were you having to do with the power? We were having to add 1 to the power, and then your coefficient was its reciprocal, yes. I don't know if I said this at the beginning of class, but we're going to go over tests tomorrow. I have them all graded. Mr. Griebel had some people who maybe were gone yesterday or Monday, so we're going to wait till tomorrow to get everybody a chance to get it taken. Sorry, I didn't say that. Okay, 3 examples. 3, that's it. 3 examples. What?
I didn't get it done. I have the last one. Thank you.
Okay. This is really how we're going to start this semester in January, is talking about antiderivatives for about 4 weeks. There's a lot to talk about with antiderivatives. But it's nice to kind of get this introduction before winter break so you don't feel like totally lost when we start in January. I think it solidifies some things that we think about with our derivatives. And you have kind of some things to think about as we head into January. Let's do and I have a Christmas worksheet about it, so I always like to do it before we start. So, here we go. Number 1. The integral, or the antiderivative of 2x to the 4th plus x cubed dx. Okay? Here I have a coefficient with my x to the 4th. Just like with derivatives, our coefficients go along for the ride. Okay?
I don't know why that's funny.
So we know that the antiderivative of x to the 4th is 1/5 x to the 5th, but we just need to keep that 2 there with it. So 2/5 x to the 5th, right? And then the antiderivative for x cubed would be 1/4 x to the 4th. And then we have plus c. Is he in the hallway right now?
He's just been walking back and
Oh, I've been missing it. Okay. Next one. Does this look like x to the n power? Okay, just like with our power rule in derivatives, our power rule with antiderivatives needs to look like x to the n before we actually use it. So we would need to rewrite this as x to the negative 2/3. Now we can take our antiderivative by increasing the power by 1 and making the coefficient its reciprocal. All right, one more example, and then you'll have time to start, maybe finish your homework. Does this look like x to the n? No. And we have nothing about, we don't have a rule about a product or a quotient or any of that. We only have really the power rule. So you can't do anything unless you have a power rule right now. So we need to rewrite this as x to what power?
2/3.
This is x to the 1/3. This is x
I
squared.
didn't see that 3. I thought it was that 3. Sloppy square root.
No.
Was it?
It'd be 2/3.
I know it's not.
It would be 7/3.
You add.
We have to add.
Ah.
So 2 plus 1/3 is 7/3.
Correct.
Okay. Okay, so, I don't know if I was convincing everybody.
Takes me back.
So now when we take our antiderivative, if we increase the power by 1, what would that be? 10/3. The reciprocal is our coefficient, and don't forget about that plus c.
This is
It's not, is it?
for this we have to find.
There is potentially one question about an antiderivative. Potentially.
Is the final how is it like AP style or more like the first part day, first day test or like the second?